Alrighty, let's take a look at a similar example over here. This is question number 12 in the section 3.2 homework or problem number 3.2.29. So as you can see, they're telling you scores of an IQ test have been bell-shaped distribution with a mean of 100 and a standard deviation of 14, and they want us to use the empirical rule to determine the following. So what percentage of people have an IQ between 72 and 128? What percentage of people have an IQ score less than 72 or greater than 128? And what percentage of people have an IQ score greater than 128? So what I did was I made a copy of our bell-shaped distribution curve. And so as you can see, they're telling us that our mean is 100 and the standard deviation is 14. So let's use that to help us with this. So again, let's go ahead and write down our mean, or you know what? Our mean is 100 and our standard deviation, was 14. Okay, so remember, right in the middle is where you will see is going to be your mean. That's X with a bar on top, which is normally what we use. Or if we're talking about population, you use the Greek letter mu, and we use the X bar if you're talking about a sample. Either way, so your mean is going to be right in the center of your bell curve, and then you start adding or subtracting your standard deviation. So if you just add or subtract the standard deviation once from the mean, you are one standard deviation away from the mean. If you add and subtract the standard deviation 2 times, so you take your mean, you subtract the standard deviation and you subtract it 1 more time, or you add the standard deviation and you add that twice, that will take you 2 standard deviations above and below the mean. Excuse me. And if you add or subtract your standard deviation 3 times, then you are going to be 3 standard deviations above or below the mean. Additionally, after that, you will also notice that even if you are at 3 standard deviations above or below the mean, you still have a little bit of that tail area, which is left behind. So you can see it's going to be these little areas, after that 3 standard deviations above or below. So it's going to be that little area over here that you still have. So, all of this, if you take into consideration everything from the left-hand side to the right-hand side, that entire curve under the area under the bell curve forms 100% of all your data values. So with the empirical rule, you have to remember what those percentages are. So let's take a look at that real quick. Okay, so here's your textbook page from this section 3.2. So you can see they're defining the empirical rule for us. So as you can see, you have within 1 standard deviation away from the mean. So, if you only add or subtract your standard deviation 1 time, you will see that's approximately 68% of your data that lies within 1 standard deviation. So that is when you have added or subtracted, 1 standard deviation from the mean. So that's going to be 68%. If you are within 2 standard deviations from the mean, so you've added and subtracted the standard deviation from the mean 2 times, you are going to be at approximately 95%. And then when you are between 3 standard deviations, you're going to be between 99.7%. So those are the percentages that, we are interested in when you're working with the empirical rule. And you can see the figure over here that also breaks it down for you. Now, you do need to remember that whenever we're talking about a bell-shaped curve, you have symmetry. So the idea is, if you look at that mean, which is going to be right in the center, that actually tells you you are going to have 50% of your data below the mean and 50% of your data above the mean. And so as you can see, because of that symmetry, we're talking about 68% within 1 standard deviation. That's going to be between, this area here. So that's 68%. which means when you divide it into its two halves, that's going to be 34% each. In that same way, when you go within two standard deviations, you're looking at 95%. So that's going to be this area over here. So that's two standard deviations away from the mean. So this entire section here is going to be 95%. So the idea is if you take 95% and divide it in half, and let me show you that on our calculator here. So we take 95% divided in half, you can see that's going to come out to be 47.5. And if you add 34 and 13.5% together, you are going to have, 47.5% on the left-hand side and 47.5% on the right-hand side. So again, that's coming from that symmetry we're talking about. And then when you go within 3 standard deviations of the mean, you are, of course, looking at 99.7. So that's going to be from here to here, and all of this area. So all of this area here is going to be 99.7. So again, if you take 99.7 and divided it in half, that's going to give you 49.85. So everything from here to here is going to be 49.85%. Everything from here to here is going to be 49.85%. So as you can imagine, you are only going to 99.7% when you are going to 3 standard deviations, which means you have 0.3% left in this tail area here and here, these two put together. So that's going to be 100 minus 99.7%, which will end up leaving you with 0.3%. Divide that by 2 and you get 0.15%. And that's why you will see each of these tails are only 0.15%. So whenever you are working with the empirical rule, you want to have this, available so it'll make your calculations easier. So that's what we're going to try and do over here is try and, bring those percentages here. So again, between 1 standard deviation above and below, you are looking at 68%. For 2 standard deviations above and below, you are looking at 95%. And then 3 standard deviations above and below the mean, you are looking at 99.7%. And that means in the tail area, you have 0.15% on the right, and same thing on the left. In the tail area, you are going to have, it's not letting me right. Let me see. Well, okay, let me see. I might have to do it up here. 0.15%. Okay, so we've kind of got a general structure going over here. So let's come back to our problem. So let's go ahead and start by figuring out what our 1, 2, and 3 standard deviations away from the mean are. So we're going to take our mean of 100, and then we're going to start subtracting and adding our standard deviation of 14 once, twice, and 3 times to figure out what those numbers on our bell curve will look like. So let's come back to our form over here. Okay. So now let's do this. So we will take 100, which is our mean, and we're going to subtract our standard deviation of 14 from it. And you can see this comes out to be 86. This number is smaller than 100. So of course, that's going to be below the mean. So you're going to put 86 over here. Then we are going to take 100 and add 14 to it, which of course comes out to be 114. And that's going to be larger than 100. So 114 will go up here. Okay. All right. So that was 1 standard deviation above the mean and 1 standard deviation below the mean. Now we have to repeat this, and we have to do 2 times the standard deviation. So you're going to do 2 times the 14 and then subtract it from the mean. And you're going to do 2 times 14 and add it to the mean. So remember, mu represents our 100. And the sigma is for standard deviation. So that's going to be the 14. So when you are doing 2 times sigma, that means you're doing 2 times 14. And then, of course, that will come out to be 28. And then you are adding and subtracting 28 from our mean of 100. So remember, this is mu, this is sigma. So again, let's take 14 multiplied by 2, which will give you 28. So now we're going to do 100 minus 28 to get 72. So that's a number smaller than 86. So that 72 will go here. And then again, instead of 100 minus 28, we're now going to do 100 plus 28, which of course gives us 128. That number is larger than 114. So 128 will go over here. So basically, remember, for this guy here, we did 100 plus or minus 2 times 14 to get the 72 and 128. So this guy gave us 72. This guy gave us 128. When we did plus or minus just 100 and with the 14, you got 86. Sorry, for the subtraction, we got 86. For the addition, we got 114. Now, the last part we're going to do is plus or minus 3 times the standard deviation. So 3 times the standard deviation. Okay, just a second here. Let's move this up a little. There we go. And then we're going to do 3 times the standard deviation. Okay, so for this guy, we are going to be doing 100, 3 times 14, and then you're adding and subtracting that value from 100. So let's see, 3 times 14 will end up giving us 42. So you're going to subtract and add 42 from 100. So 100 minus 42 will give us 58. That's going to be this number here. And then, of course, 100 plus 42 will end up giving us 142. So that's 3 standard deviations away from the mean. If it will let me write 142. Okay, so of course 58 will go below. Let's remove some of these markers so I can write our numbers down. Okay, so 58 over here, and then 142 over here. Okay, so now let's get back to our question. So they wanted to know what percentage of people have an IQ score between 72 and 128. So you will see 72 and 128 actually fall in the second standard deviation from the mean, because you can see 72 is the mean minus 2 times the standard deviation, and 128 is mean plus 2 times the standard deviation. So that comes out to be within 2 standard deviations. So that's going to be 95%. So for this guy, we're just going to say it's going to be 95% of the people will fall between IQ scores of 72 and 128. All right, now they are talking about what percentage of people have an IQ score which is less than 72 or greater than 128. So let's come back to our bell curve over here. So they are talking about less than 72 and greater than 128. Again, I'll show you that. Less than 72, greater than 128. So they're actually talking about people over here. So this is going to be less than 72, and this is going to be greater than 128. So it's going to be everybody, you know, who falls into this little section here, and everybody who falls into this little section here. So we just in part A said everybody who falls between 72 and 128, which was this section of the bell curve, was 95%, right? Which means if the center, all of this here is 95%, then out of 100%, you subtract 95, and that tells you only 5% of the people are going to fall in the less than 72 and the more than 128. So that's how you calculate, because that's the remaining part of the people. So 5% of the people are going to be less than 72 and greater than 128. So let's take a look at that. So that will be 5%. Let's clear this out. And you're going to say 5% over here. All right, wonderful. And then the last part was asking, what percentage of people have an IQ score greater than 128? So let's take a look at that. Greater than 128 is only going to be this section over here. So right now we calculated that there were 5% people who were less than 72 and more than 128. So if 5% of the people are for both of these sides, then of course you just take its half, right? Divide that by 2 and you will get 2.5% people. So that tells you 2.5% of the people fall in the category of greater than 128, and 2.5% people fall into the category of less than 72. So right now they are only interested in greater than 128. So that's going to be your 2.5%. So again, let's come back over here. And this is going to be 2.5%. And that's all you have to do in this. So you're just using the empirical rule to come up with these percentages. So I hope this helps you out. All right, take care and good luck. Let me know if you have any questions.